Hello everyone. Okay, so in this video, the final video on the modulus, we're looking at modulus inequalities. So we can apply our knowledge of modulus to modular inequalities as well. So if I have here the modulus of x is greater than 3, then x has to be greater than 3 or x has to be less than minus 3. That makes sense because if x equals minus 4, well, the modulus of minus 4 is 4. So that's why x has to be less than minus 3. And x has to be greater than 3 because the modulus of like 4 is equal to 4. The modulus of 5 is equal to 5. And all of them are greater than 3. The other thing that holds up with modulus is also if I have a modular equation like inequality like this, the modulus of x plus 2 is greater than 4. How I get rid of it, or my modulus, is I square both sides like we were when we were solving equations, and then solve and plot the resulting quadratic. So let's look at an example now. So solve x, the modulus of x minus 6 is less than 2. So I want to plot this modulus out. So 1, 2, 3. So I'm labeling my axes 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So I want to plot my modulus out. So get my 3 points. So x, first point, let the inside of my modulus equal 0. So x minus 6 equals 0. X is equal to 6. My first point is 6, 0. 6, 0. There it is. Next point, I need 1 to the left and 1 to the right. So I'm going to choose x is equal to 5. So 5 minus 6 is equal to the modulus of minus 1, which is equal to 1. So my next point is 5, 1. So 5, 1 is here. And then I'm going to pick a point to the left. I'm going to pick 7. Or so I pick a point to the right. So I'm going to choose x is equal to 7. So x equals 7. I'm going to have 7 minus 6 is equal to modulus of 1, which is equal to 1. So my point here is going to be 7, 1. So that's my next point here, 7, 1. So let me connect these up. And let's do it here. Right. So it's asking me here, solve where the modulus is less than 2. So we go to 2 on my graph. Here it is. Draw a line across. So I'm looking for the values where it is less than 2. So I am looking for the range of these values, right? So if I was looking for the greater than 2, I'd be looking at these values here, but I'm not. I'm looking for less than 2. So I'm looking for this blue region here. So I'll read my points go down. So x is going to be between 4 and 8. So my inequality is just going to be 4 is less than x, which is less than 8. That is when my inequality is, or my modulus is less than 2. Gorge. Then I could do this algebraically as well. So if I do this algebraically as well, so I have x minus 6 less than 2. I square both sides, so x minus 6 squared is less than 2 squared. So it'll be x squared minus 12x plus 36 is less than 4. X squared minus 12x plus 32 is less than 0. So solve, I have x minus 8, x minus 4. They multiply to get 32, but I have to get minus 12. So equals 0. So I have x is equal to 8 and x is equal to 4. Plot out my quadratic roughly. 4 and 8. 4, 8. And then less than 0, so below x-axis. So this region here, that's 4, that's 8. Well, again, that's going to be 4 is less than x, which is less than 8. So there's me solving it both algebraically and graphically. So let's look at some past exam questions. So This one here is from the 2020 paper. So this one didn't ask me to do a graph. This just said find the range of values for x for which the modulus of 2x plus 5 minus 1 is less than or equal to 0. So what I need to do is square both sides. So 2x plus 5 squared is less than, and bring the 1 over, is less than or equal to 1 squared. So bring it over, square both sides. So you can get the modulus on its own and then square it. So I have 4x squared, and I think it's going to be 20x plus 25 when you expand it out is less than or equal to 1. 4x squared plus 20x plus 24 is less than or equal to 0. So less than or equal to 0 below x-axis. Right. So I need to solve this now. I notice here I can divide across by 4. I can divide across by 4 because it's positive, so I don't have to worry about changing the sign. So I have x squared plus 5x plus 6 is less than or equal to 0. So solve this out. I'm going to get x plus 2, x plus 3. So x equals minus 2 and x equals minus 3. Roughly plot it out like this. So minus 3 is going to go here. Minus 2 is going to go here. I'm looking for less than 0, so below the x-axis. So it's trapped. I'm going to have a compound inequality. So I have minus 3 is less than x, which is less than minus 2. And that's my answer there. Right, let's look at this one. This is from the 2016 paper. Paper 1, question 2. Find the range of values for x for which the modulus of x minus 4 is greater than or equal to 2. So that's going to be x minus 4, all to be squared, is greater than or equal to 2 squared. So I'm going to have x squared minus 8x plus 16 is greater than or equal to 4. Bring the 4 over. I'm going to have x squared minus 8x plus 12 is greater than or equal to 0. Solve it. So two numbers are multiplied to get 12, but add to get minus 6. It's going to be x minus 2 and x minus 6. So I'm looking at greater than or equal to 0. So I'm looking at above x-axis. So my roots here are going to be x equals 2 and x equals 6. So plot it out here like so. 2, 6, greater than, ding, 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 ding. So x has to be less than 2, but x is going to be greater than 6, and that is my answer there. Gorge. Right, 2 questions left. So this one is from 2007. So plot on the number line, okay, the values of x that satisfy the inequality x plus 1 is less than or equal to 2. So I first now have to solve this inequality and then I have to plot it on the number line. How fun. So where x is an element of integers. So whenever I'm plotting on a number line, integers means dots. So I'm doing dots, right? I'm not doing lines, I'm only doing dots. So let's solve this out now. So x plus 1 modulus less than or equal to 2, square both sides. X plus 1 squared is less than or equal to 2 squared. That's x squared plus 2x plus 1 is less than or equal to 4. Bring the 4 over. I have x squared plus 2x minus 3 is less than or equal to 0. Factorize and solve this. That is going to be minus 3 and x plus 1 is less than or equal to 0. So less than or equal to 0, I'm looking at below x-axis. So I have x equals 3, x equals minus 1. So plot it out. Ding. Plot it out. So this is going to be minus 1 and this is going to be 3. And then I'm looking for the region that's less than 0. So I'm looking for the trapped region here, and that is going to be minus 1 is less than or equal to x, which is less than or equal to 3. But I'm not done just yet, because it asked me in the question to plot it on the number line, which is really sneaky. So I have to plot all the integers between -3, so -1 and 3. So I'm just going to draw a little line here. Right? So, -1, -2, 0, 1, 2, 3. So, I'm plotting this number line. -1 is included, 0 is included, 1 is included, 2 is included, 3 is included. I'm not going anymore because 4 is not included and -2 is not included. So that is my solution set plot on a number line. And remember, x is an element of integers, so I'm using dots. If it was an x was an element of real numbers, I'd be doing a big thick line, but in this case it's just dots. Right, and finally the last question here. Last question asks us, this is from 1986. Plot the following modulus and find the values of x that satisfy the modulus of 1 minus x is less than 5. So I need to plot this modulus. So let me take out my ruler. And then that should be enough. Grand. So that's going to be 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6, 1, 2, 3, 4, 5, 6, 7, 9, 10, 4, 5, 6, 7, 8, 9, 10. Probably a bit overkill, but you never know. Always do a big graph. So, you need to plot this modulus 1 minus x. So first I'll let it equal 0. So I'm going to get x is equal to 1. So my first point is 1, 0. So I'm going to plot that first. So my first point is 1, 0. So 1, 0, that goes here. So I need a point to the left and I need a point to the right. So my left point might be x is equal to 0. So I have 1 minus 0. It's going to be equal to the modulus of 1, which is equal to 1. So it's going to be 0, 1 is my next point. So 0, 1, that's going to go here. And then my last point is going to be, so I'm going to pick x is equal to 2. So I need 1 point to the right. I'm going to pick x is equal to 2. So I have 1 minus 2 equals the modulus of -1, which is equal to 1. So another point I have is 2, 1. So plot that here, 2, 1, that's going to be right here. Plot out this modulus. Hopefully I did a good job now plotting this. Alright, there you go. Right. So, I'm looking at where it is less than 5. So go to 5 on my thing here. I think this one's a bit wonky here. Let me just fix that up. So I'm really going through these 2 points here. Ding. Ding, like so. Sorry, not my best. It's very hard to do this on an iPad. You're going to have an actual thing. Right, so plot it out. Like so. Oh no, I want a different colour. Plot out here. So I'm looking for the values less than 5. So I'm looking for the trapped values here. So I'm looking for these ones. And when does that happen? That happens at this point and this point. So when x is going to equal -4 and x is going to equal to 6. So my range of values here is going to be -4 is less than x, which is less than 6. And that is my modulus inequality there. We could check my answers using algebra. So I'm just going to quickly do that. So 1 minus x to see how far off or correct I am. So I have the modulus of 1 minus x is less than 5. So 1 minus x is equal to plus or minus 5. So 1 minus x is equal to 5. 1 minus x is equal to minus 5. Minus x is going to equal to 4. X is going to equal to minus 4. And minus x is going to equal to minus 6. X is going to equal to 6. And they are the two values I pointed out there. So I am correct. So there were some questions there on modulus inequalities. And I hope this video was some help to you. And I'll catch you guys later. Bye.